Streaming access to ADCS and DACS for mixed signal ATPG. Introduction. Plant to sensor or transducer to anti-aliasing filter to sampling and hold, analog digital converter to computer or digital signal processor, DA converter, smoothing filter, analog signal, plant, sample and hold operation, smoothing staircase. External world physical signals such as temperature, pressure, vibration, etc. are converted to electrical signal for processing or analog signal. It is difficult to process and store analog signal, therefore we convert them to digital to process and back to analog signal. From external world, physical signal is converted to electrical signal by sensor, and that signal is converted to band limit signal by using anti-aliasing filter to satisfy Nyquist criteria. The band limited signal is sampled at a rate twice more than max frequency of band limited signal, and it is held constant until it is converted to digital by ADC. Then the sampled voltage is converted to digital form to process and store the data. Then based on digital input, DAC converts digital data into analog signal. The output of DAC is staircase. So its output is passed to smoothing filter to smooth the waveform. Digital to analog conversion. From 3-bit DAC to V reference equals to 5 volts. Here V out equals to K into V reference D by 2 power N, where D is digital word. For example, 3-bit DAC, if input word is 110, then D equals to 6. 3-bit DAC, N equals to 3. V reference is the voltage applied to DAC. K, DAC gain. Generally it is 1. Example for 3-bit DAC, if input word is 110, V reference equals to 5 volt, then D equals to 6, N equals to 3. Therefore V0 equals to 5 into 6 by 2 cube equals to 3.75 volts. R2R DAC. Here switch is either connected ground or to V reference basic digital input. To find V0 we use Thevenin's equivalent analysis. Thevenin's equivalent circuit for binary value B2, B1, B0 equals to 0, 0, 1. Where V equals to 2R into V reference by 4 by 2R plus 2R equals to V reference by 8. Thevenin's equivalent circuit for binary value B2, B1, B0 equals to 0, 1, 0. 2R plus R equals to 2R. Thevenin's equivalent circuit for binary value B2, B1, B0 equals to 1, 0, 0. Generalized result. For B2, B1, B0 of 1, 0, 0, the value is V reference by 2. 0, 1, 0, V reference by 4. 0, 0, 1, V reference by 8. Whenever more than one bit is 1, then output of ladder network is sum of output voltages. For example, when all 3 bits are 1, 1, 1, 1, V reference by 8 plus 4 plus 2, 7 V reference by 8. Therefore, output of ladder network is R2R network equivalent R resistance is R. For n-bit ladder network, VR minus 2R, V reference into summation of V0 by Z to the power of N. Final volt equation. V reference, V output equals to V reference of minus RF by R into P0 by 2N plus B1 by 2N minus 1, so on. V0 equals to minus V reference into RF by R summation I from 1 to N minus 1 Bi by 2 power N minus I. Analog to digital converter ADC. Analog to digital converter. For 3-bit ADC and for V reference equals to 5 volts, Counter type ADC. In analog to digital converter ADC, the counter is reset to 0 by count pulse and input voltage VA is applied to comparator. Upon the release of reset clock is applied to binary counter and pulse are counted by binary counter. The number of pulses counted increased with time. The output of binary counter is input to DAC, which converts binary value in analog voltage. This voltage is compared with comparator when output of DAC VD is less than input voltage. When output of DAC becomes equal to VA, output of comparator becomes 0 and AND gate disables clock pulse to counter. Here counter frequency should be less to allow DAC for its conversion. Worst case delay is 2 power n minus 1 of t, where t is 1 by clock frequency. Successive approximate ADC. It takes n clock cycles to complete a conversion. It has successive approximation register and DAC. Initially, SAR sets MSB D7 equals to 1 with all the other bits to 0, i.e. 1, 0. With output VD of DAC is compared with analog input VA. If VA is greater than VD, then MSB is left at 1 and it remains. If VA is less than VD, then MSB made 0 and output of SAR becomes zeros. This is repeated for all subsequent bit 1 at a time until all bits position have been tested. When conversion complete, EOC signal produces end of conversion signal. Example. Thank you.